So yesterday we have seen about the association rule generation, different association rule methods, etc. And now we are moving to the correlation methods, correlation rules. So in order, so sometimes strong association rules are not necessarily interesting, not always interesting. So in order to mine the strong association rules, which are also interesting, we need to go for the correlation analysis. This is also a revision. This is also a revision of the previous classes. Okay. So to get the correlation rules, here along with the support and confidence measure, correlation measure is also added. Along with the support and confidence measure, correlation measure is also added. So here is the form of the correlation rule. So if a rule is a correlation rule, it satisfies certain support and confidence. Along with that, it should satisfy certain correlation. So how to find support and confidence? We already know that. But how to find the correlation is for this we have certain methods to find out the correlation among the item sets. So we are having four correlation measures: lift, chi-square, all confidence and cosine. I think you are very familiar with the chi-square method. That is already covered in your second chapter. Coming to the correlation method, how to calculate the correlation among exist among the items, let us see now. So coming to the lift, the correlation measure lift is obtained from this formula. Lift of AB is equal to P of A union B by P of A into P of B. So here, if the lift among the items at A and B is equal to 1, then we can say that there exists no correlation among the item sets, which means that item sets A and B are independent. If at all the lift value is less than 1, then there exists a negative correlation among the item sets. And if it is greater than 1, then there exists a positive correlation among the item sets. What is that positive correlation and negative correlation? Positive correlation in the sense sales of A may lift or may increases the sales of B. That means both the sales of A and B are positively correlated together, related together. So sales of one item depends the sales, affects the sales of another item. The effects in the sense that may be the negative effect or positive effect. If the sales of one item negatively affects the sales of another item, then it can be represented as a negative correlation. If the sales of one item positively affects the sales of another item, then it can be represented as a positive correlation. So, if at all the lift value is less than 1, we can say that there exists a negative correlation exists among the items at A and B. And if at all the lift value is greater than 1, then you can say that there exists a positive correlation among the items at A and B. If at all the lift value obtained from this equation is equal to 1, then you can say that there is no correlation among the item sets, which means that item sets A and B are independent. Independent in the sense sales of A does not influence the sales of B. Similarly, sales of B does not influence the sales of A, like this. Coming to the other method, that is my system is getting stuck. Wait for a while. So here is an example of a data set consisting of games and videos. Here, a total of there are 6,000 transactions consisting of only games and 7,500 transactions consisting of only videos, items consisting of only videos. Whereas here, this 4,000 indicates that the transaction consisting of games but doesn't contain any videos. And here 3,500 are the number of transactions which does not contain both games and videos. Similarly, here 2,000 indicates that the transaction which consisting of both game and video. Similarly, here also 500 indicates the transaction which does not consisting of videos and games. Okay, here this bar indicates the absence of that item in the transaction. So here from this we need to first calculate the lift among the items like game and video. For this is the formula for lift as previously we have seen. So for this, we need to calculate P of A union B and P of A and P of B. Let's go with P of A. P of A is the sense P of game. Probability of purchasing only games. So here probability of purchasing only games is 6,000 by total of 10,000, which is nothing but 0.60. And probability of purchasing only videos is here is the video 7,500 by 10,000, which is nothing but 0.75. And probability of purchasing both games and videos is this is the figure. Probability of purchasing both games and videos is 4,000 by 10,000, which is nothing but 0.40. And by substituting all the values here, you can get the lift value as 0.89, which is less than 1. As we have seen previously, if the lift value is less than 1, there exists a negative correlation among the items. So here there exists a negative correlation among the items like games and which means that sales of uh, games may decreases that means increasing the sales of games may decreases the sales of videos. Similarly, may increase if the sales of videos is gradually increasing, then it affects the sales of games like this. So here is the rule derived from this with the support of 40% and confidence of 60%. But actually, if you only consider the support and confidence framework, you can say that these are strong association rules. But such a negative correlation which obtained by including the correlation measure is you can't find that negative correlation from only the support and confidence measure. So it is very important to inculcate the correlation measure also while if you want to mind the strong association rules which are also interesting. Next, coming to the chi-square measure, here is the formula for the chi-square measure. So here the chi-square value tests the hypothesis which says that A and B are independent. The test is based on the degree of freedom. In our example, it is 1. In this example, it is 1 actually. Here, for the same example, this is the formula. So here we are only having the observed value. We are only having the Here we are only having the observed values. And to get the expected value, here is the formula count of A into count of B by N. So first, before going to substitute the before going to implement the chi-square equation, we need to calculate the expected values. We need to calculate the expected values. How to get the expected value? So for this observed value, what is the expected value? Count of A into count of B by N. So for this observed value, count of A in the sense you need to go for this line, count of B in the sense you need to go for this line. So count of A is this one and count of B is this one by N. That means 75,000, 7,500 into expected value can be obtained as 7,500 into 6,000 by total number of transactions. Hope my voice is audible, right?
Yes, ma'am.
Okay. So by doing this, you can count of A 6,000 into 7,500 by 10,000. Yes. By doing this, you can get 4,500, which is nothing but the expected value. Like this, you need to find out the expected value for all this. So here is the table consisting of the observed values along with the expected values, and from this second table, you can get the chi-square value. So just to substitute the values in the formula, observed minus expected. What is the observed here? This is the observed value and this is the expected value. Whole square by expected. Again, 4,500 plus here is a sigma, right? Plus again observed minus expected by expected whole observed minus expected whole by expected, and again from this Here observed minus expected whole square by expected. And from this here observed minus expected whole square by expected. Like this, you get the chi-square value as 555.6. So here you get the degree of freedom as 1. Here you get the degree of freedom as 1. So for 1 degree of freedom, the chi-square value is 1. So for 1 degree of freedom, here is a statistical table. You can find it in net generally. In Google, you can get the statistical table for the chi-square value. So for 1 degree of freedom, at the significance level of 0.001, you get the chi-square value as 10.828, which is actually less than the obtained value. So if at all the actual chi-square value present in the statistical table is less than the obtained value, then we can reject the hypothesis. Actually, what is the hypothesis? A and B are independent. That is the basic standard hypothesis for the chi-square test. So here, with our test, we are rejecting the hypothesis in the sense we are saying that A and B are dependent. So we are saying that A and B are dependent. That means from this chi-square test, we can conclude that game and video are correlated together. Game and video are correlated together. And let's come to the other two methods, correlation methods, all confidence and cosine. And here is the formula for the all confidence method, and this is the formula for the cosine among the items sets A and B. And for the same example, let's find out the value for the all confidence measure. Here, support of x by maximum item support of x. So, support of x in the sense x is the item set. X is the item set consisting of both games and videos. So, support of x in the sense 4,000 because it includes both games and videos. This is the number of transactions including both games and videos is 4,000. And by maximum item support. Maximum item support out of these two, here support for games is 6,000 and support for videos is 7,500. Uh, Actually, this is a revision class, but in the last class when we are dealing with this particular topic, we have some internet connectivity issue. That's why I'm going in details into this concept. Okay. So here we need to consider the maximum item set support. So out of these two, which one is the maximum? This one is the maximum. So we need to consider the 7,500 here, and totally we are getting 0.53 value for all constants measure. Similarly, we need to go for the cosine also. Here the formula is P of A union B by square root of P of A into P of B. Similarly, we know that P of A union B is equal to 4,000 and square root of P of A is 6,000 and P of B is 7,500. And we are getting the value as 0.60. So here are the observations. If at all the values, the conditions are same for both the measures, all constants and cosine. If the obtained value from the measures is equal to 0.5, then there is no correlation among the items. That means no correlation in the sense items are independent completely. So if at all the value is less than 0.5, then there exists a negative correlation. If at all it is greater than 0.5, then there exists a positive correlation. So from this example, here what is the value obtained from all constants? What is the value we got
0.60.
for all constants?
0.53, ma'am.
53. So since 0.53 is which it satisfies which condition?
Greater than 0.5, ma'am.
Greater than 0.5. So since we get the value which is greater than 0.5, so it is concluded from by observing the all constants measure, the conclusion is that the item sets are positively correlated. Similarly, observe the cosine measure. So what is the cosine value obtained? What is the cosine value we obtained?
0.60, ma'am.
60. So which is greater than 0.5. So here
0.5.
here also the conclusion is what? There existed
Positive correlation, ma'am.
positive correlation among the items like A and B. So here if you observe the lift measure, chi-square measures expresses that there exists a negative correlation among the items. But here, all constants and cosine methods expresses that there exists a positive correlation, because this is our conclusion actually. There exists a positive correlation among the item sets A and B. But all these four are comes under what? Correlation measures. All these four are correlation measures, but these two says that there exists a negative correlation. For the same example, these two measures says that there exists negative correlation, but these two measures says that there exists a positive correlation. Then which one to follow, which one to trust actually? So here there is time to decide out of four correlation measures. All are correlation measures, right? So out of four correlation measures, which we need to depends on uh, whose output we need to depend. We need to know that. We need to conclude that. For this, we need to go for the topic called null transaction. So to decide which measure is best, or which measure to trust, or which measure we need to give the higher priority, and which measure you need to give the lower priority, whose value you need to follow. For this we need to find. We need to go for the concept of null transaction. A null transaction that does not that does not contain at least one item set that is being examined is referred to as a null transaction. Okay, it does not contain at least one item set that is being examined. So what are the null transactions here? Here, if you observe this is null transaction because it includes games and videos. If you observe this, even though it doesn't include the video, it includes games. At least one item is there here. So it is also not a null transaction. So if you observe this here, even though it does not include games, but it includes video. So it is also not a null transaction. But here, these 500 transactions does not include either of the games and videos. But our main concentration is here. Our item set X includes the items, games, and videos. But here, these 500 transactions that does not include the items and videos and games. So these are comes under null transaction. So if a measure is not influenced by the null transaction, then that measure is called a null invariant. So the four measures, if the measure is influenced by that means if the measure uses that value 500, that means it is influenced by the number of null transactions. If at all it is not influenced by the null transactions, then that measure is called as null invariant. So null invariant is a required, very important property for measuring the patterns. So here, among the correlation measures, among all the correlation measures, lift and chi-square are not null invariant, and the remaining two are null invariant. So why, how we can say that those two are null invariants and those two are not null invariant? Let's go with an example. Here, if you consider this, we are similarly, just like a previous example, we are taking here three data sets. Here we are taking three data sets. So we have calculated all the measures, all constant, cosine, lift, chi-square for all the three data sets. And if you observe that the all constants and cosine values for all the three data sets are same, right? For all the three data sets, the values for these two measures are same. The values for these two measures are same, whereas the values for these two measures are vary for the three data sets. Why? Because if you observe that the value for the first column is same for the three data sets, and the second column is also same, third column is also same, but observe the fourth column, it varies. What indicates the fourth column? What is this? Just now I told. What is this? This is
Null
the
transaction, ma'am.
yes, very good. This is a null transaction. So here for each data set, number of null transactions are different. So for each data, number of null transactions are different. So because these two measures, 1 and 2, if I consider this is 1, this is 2, and this is 3, this is 4, the measures 1 and 2 does not depend or does not influence on the number of null transactions. So irrespective of the values we have present in GB bar, we are having same values. We are getting same values for the 1 and 2 measures. But the measures lift and chi-square are depends or influenced by the number of null transactions. So because of this, even though the values for the first three columns are same, we are getting the different values for the lift and chi-square. So here from this we can conclude that the measures 1 and 2 are not influenced by the null transactions. So those measures 1 and 2 are obeying the null invariant property, whereas the measures 3 and 4 are influenced by the null transaction. So those measures are not obeying the null invariant property. So we can blindly go for the results of first two measures. If at all those results are resulting in some weakly positive or weakly negative manner, then only. So if at all the results of first two measures are a little bit varying or weakly become weakly positive or weakly negative, then only you can go for the lift and chi-square method. So our always our first priority is among the four measures is on all constraints and cosine measures. And let's coming to the next topic. This is not the revision class. Till now we have finished the revision of the third unit, and this is the last topic in your third unit. Constraint based association mining. So it is a strategy of instructing conditions, also called as constraints, on the mining process. That means we are putting some rules, we are putting some conditions on the mining process. What is the condition? Here we're having certain constraints. You need to join to the meeting or join to the class only when the host initiates the meeting. That is the constraint. Otherwise, you can't join the meeting, right? Only when the host initiates the meeting, you can enter into the meeting. That is a constraint. You can go for the movie only. You can get the ticket. That is the constraint. Constraint is a small rules. So here, constraint-based mining, association mining, we are mining the association rules by following certain constraints. So this is a strategy of instructing conditions, also called as constraints. Those conditions are called as constraints. On what? Here, constraints are on the mining process. So those constraints makes the search process more effective. So those constraints makes the search process more effective. For example, if anybody uh, when, are ever tried to search a research paper in any Google Scholar or in any IEEE Springer journals, if you try to search for a research paper, suppose your research topic is, for example, data warehousing. Data warehousing system is your research topic, and you need to search for the research topics from the some IEEE Explorer. So if at all you're just entering the key, the what is that data warehousing system, you may get thousands of results because there exists a lot of research already done on the topic of data warehousing. So if at all you just simply wanted to search using the keyword data warehousing, you may get thousands of results. So what to do? It is very difficult to go through all the thousand results. So actually your interest is on retrieving the research papers on data warehousing subject only which are published in the year 2019 and 2020. For example, your interest is only on that. So there are you can observe that just you can go through that after the class. You can go through that. You can try to retrieve some papers. It is a very best practice which also helpful for your doing your final year project also. So just try to add some filters to that search. There you can find some actions, add some filters like that. So there you can mention your year. So whenever you mention year from 2019 to 2020, your search is refined, and only maybe 100 or 200 papers which are only published in the years 2019 and 20 are retrieved. So your searching space is reduced automatically, which decreases the strain and which enhances the effectiveness of searching process. Like that. and that too, you are more specific towards the research papers which are published in journals, not published through conferences. So again, you can add some filters. There you can only select the journals. So there your search is confined to some 150 papers. So like this, you can make your search space effectively. You can compress the search space, which increases, which enhances your searching process. So like this, here also we are having certain constraints on the rules you need to mine, which confines the search space for mining process. So we are having different constraints. Different constraints that exist. Coming to that, knowledge constraint, data constraints, and dimensional or level constraints, interestingness constraints, rule constraints like this. So coming to the knowledge constraints, these are the constraints on the knowledge you want to extract. And here the data constraints or the constraints on the data. That means which data particularly you want to extract from the overall large data warehouse. Which part of the data you need to extract. Similarly, dimension or level constraints. Which dimensions among all the dimensions exist? Which dimensions of the data set you want to extract? Similarly, interestingness constraints. So out of many measures we are having, which interestingness measures you want to impose your search? What are the measures we are having? Support, confidence, lift, chi-square, etc. we are having. So out of all these measures, interestingness measures, which measures are which measures you want to impose on your search? Similarly, rule constraints. So these constraints specifies the form of rules to be mined. Like this, you are having different constraints exist. And coming to this meta rules. Coming to the meta rules are the syntactic form of rules, also called as rule templates, and act as constraint for effective mining process. So what is this meta rule? What is this constraint? Let's go for an example. Go with an example. So here, briefly, the meta rule is just like a blueprint or template. So based on that meta rule, you can form the actual rules. So here is an example of the constraint, meta rule, and the rule which can be generated from the meta rule. So coming to the constraint, here determining which parts of customer traits promote the sales of office software. So here the constraint is determining which parts of the customer traits promote the sales of office software. So based on which the office software sales are promoted, based on which customer traits the office software sales are promoted. This is the constraint given. So here is the meta rule based on that constraint. Here P1 of x comma y and P2 of x comma w implies bisect of office software, where here P1 and P2 are the predicate variables, and here y and w are the values of the predicate, and here is x indicates the customer. Okay, and this is the rule which is generated, which is mined based on this meta rule. Since I already told that meta rule is nothing but is act as a template. So based on that, you can generate our actual rule. So here, as it is based on the meta rule, we are generating our actual rules. So here, the predicate variables are age and income, and the values for the predicate variables y and w are here. 30 to 39, and income is from 41 to 50. These are the values for the predicate variables. So here, what is the meaning of this rule? So if at all the age is between 30 to 39 and income of x is 41 to 50,000, then he may probably buy the office software. So in this way, you can, based on certain constraints and based by following the meta rule, you can extract the actual rules. So here, meta rules allows us to specify syntactic form of rules that they are interested in mining. Meta rules form a hypothesis regarding the relationships that the user is interested in probing. So this is all about the meta rule. Here is how we can mine based on the rule constraints given. So what kind of constraints can be pushed deep? That is, can be stressed in mining process. So for this you can consider an example. Here is the query. Here is the example query. Find the sales of which cheap items may promote the sales of expensive items of the same group for Chicago customers in 2004. 2004. This is the data mining query given. This is the given data mining query, and these are the given relational tables. Sales, lives in, item, transaction ID. So here, if you consider the lives in table, what is the primary key? Is there any primary key? Otherwise, consider the transaction table. What is the primary key here? I think you can able to follow the class. What is the primary key from this transaction table? Are you able to listen my voice? Are you able to hear
Yes,
me?
ma'am.
What is the primary
Yes, ma'am.
key? Just I'm asking, just try once. What is the primary key for this from this transaction table?
Transaction ID, ma'am.
Transaction ID. I think you have you already done with the subject DBMS, right?
Yes, ma'am.
In your previous semester, right?
Yes, ma'am.
Yes. Then
No.
here from the transaction table, PID is the primary key. Primary key based on which you can go for the search on that table. Similarly, in the item table, item name is the primary key, and here from the customer in the lives in table, customer name is the primary key. Since in the sales table we are having customer name from lives in and item name from item table and PID from transaction table. So we can call that means sales table is linked to all these three tables. So we can also call as sales table is the parent table and all the three are the child tables like that. You can describe. So here is a data mining query given to us. Find the sales of which cheap items. What is the meaning of this query? So they are asking that we need to find the sales of expensive items. We need to find the sales of expensive items, which are depends on the sales of the cheapest items. For example, if I mention like this, some A B may gives rise to C, which indicates that C is a costliest item, where AB are the cheapest item, and the sales of AB together leads to or causes to the increase in sales of C, conditioned that the prices of items, sum of items of A and B should be less than 100, and the price of the item C should be minimum of, that means it should be greater than or equal to 500. So they are asking, we need to find out the which cheapest items leads to the purchase of or leads to the sales of the costliest items, and they have also mentioned some conditions. What is the condition here? Of the same group. So those items A, B, and C are from the same group, and the city should be the Chicago, and the year should be the 2004. All these are the constraints they have mentioned. So this is the query given, and this is the generated data mining query language for the given query. That is generated data mining query language. What that query indicates, uh, go in, how to evaluate that query. Let's leave that for now. You can get it in the later topics. So here, from this query consisting of 8 lines, just observe the query once. Here, the first constraint is out of we are having different constraints, right? Knowledge, data constraint, dimensionality or level constraint, interestingness constraint, rule constraints, etc. So out of all these, the first constraint is knowledge type. So this is the constraint for knowledge type. Knowledge in the sense whether going to mine the association rules or correlation rules. Which kind of knowledge you are going to mine. So here line 1 indicates the knowledge type constraint. So here next constraint is data constraint. So observe lines 2 and 3. The customer lives in Chicago and here from sales. So these two represents the data constraint. That means here they are specifying that we need to go for the sales, and here also they are specifying that you need to go for the lives in table, and particularly you need to go for the customer name and Chicago, like that. So these comes under data constraints. And coming to dimensionality or level constraint, here in lives in table, coming to the table part, here lives in table, you want the customer name, you want the city, right? You want the customer name and city. Region you don't want. So these two are comes under dimension table, and that means which dimension you want to retrieve. So similarly consider the item table. So item name you want, again group you want, price also you want to consider. Similarly from the transaction table, transaction ID and year. You don't go for the day and month. So all these are the comes under data constraints. So since it is 10:50, I'm going to end this session, and I will going to continue this topic in the next class. Okay, submit your assignments by 12th midnight, and after that I don't allow you to submit till I think 40 members are submitted the assignments. So whoever submitted the assignments can get good marks. That's it. There is no need of requesting you to submit, etc., etc. Okay. Thank you all.